Εδώ είναι εντάξει? Είναι καλή και η απόσταση? Ίσως λίγο πιο κοντά, να το φέρω εδώ. Τώρα? Να μιλήσω, να πω λίγο... Α, θέλει πιο δυνατά, εκεί. Ωραία. Ωραία. Εάν κάτι χρειαστεί, μπορείτε να σταματήσετε και να μου πείτε εσείς κάτι πιο δυνατά ή ό,τι. A structural system is characterized by the materials used for building construction, the architectural form of buildings, the actions imposed to the structures, and the type of bearing elements and their connections. Nowadays, almost identical architectural forms are used all over the world, irrespectively of the local climatic conditions or of the actions expected to be imposed to the structures. On the contrary, looking at older structures, one can distinguish, for example, between buildings constructed in mountainous regions and those built on an island with rare rainfalls, etc. Historical structures in Greece are made of masonry, stones, adobe or bricks connected with mortar, whereas timber and or metal ties may be used to reinforce masonry. There is a vast variety of ways in which stones or bricks and mortar are combined to form the faces of masonry. The same holds true for the ways masonry is constructed within the thickness of masonry elements. Let us now examine the mechanical characteristics of masonry. The mortar plays a triple role in masonry. It connects stones or bricks, it smoothens their angles, it fills voids of masonry, thus ensuring habitability. It is, however, the weak material, as its compressive strength is by 1 or even 2 orders of magnitude smaller than that of stones. The tensile strength of masonry is very small. Therefore, masonry is working well under compression, but very poorly under tension. Moreover, masonry fails under very small deformations. Thus, the following aspects are very important for masonry structures. 1. The box action. The cube that consists of walls, floors, and roof is not deformable. If we reduce the number of sides of the box, then the box becomes more deformable. Thus, the occurrence of damages to masonry becomes more probable. This is also the case when the walls are not well tied together in the corners of the building. 2. We should avoid large openings, doors and windows, because in that case, the available area of masonry is reduced and the flow of forces deviates from its vertical path. Furthermore, large openings have long lintels which are vulnerable to bending. The question arises then, did the old constructors take care of all those aspects? Yes, they did, as structures survived to date show. For example, we distinguish the elaborate construction of the corners of a building, the careful construction around openings, etc. Let us now talk about the phenomenon of the earthquake. An earthquake is a ground motion generated in the earth crust. The motion travels from the epicenter to where our structure stands. In a simplified way, we may assume that for an acceleration of the earthquake equal to ag, the building is subjected to an inertial force which is equal to ag times the mass of the building. When a masonry element is parallel to the direction of the motion, it is subjected to in-plane shear. As shown in the sketch, due to shear, the length of one diagonal is reduced, whereas the length of the other diagonal increases. Thus, along AC, masonry is in tension and it may crack. When the direction of the motion changes, the other diagonal BD is in tension and a new crack may appear. You are invited to observe the damages and to comment on them. When the motion is perpendicular to a masonry wall, vertical cracks may appear at mid-span of the wall and or close to the connection with transverse walls. Again, observe the damages and provide comments. The question arises as to whether there are ways for improving the behavior of historic structures and thus limit their damages. Let us assume that we place a timber tie at mid-height of a wall subjected to shear. The timber element is in tension. The tensile strength of timber is high. Thus, either the opening of the crack is prevented, or if the crack opens, its width is limited. Were the old constructors aware of the contribution of timber elements? Yes, they did. And they applied these solutions systematically since at least 2,500 years before Christ. Again, you are invited to observe the use of timber reinforcement through the centuries in many types of structures. In Greece, there are numerous historic centers in which the use of timber ties is systematic. As you can see, the role of timber ties is multiple. As literature proves, the constructors were conscious of the role of timber ties. However, in several cases, they were making mistakes. The disadvantage of timber is its limited lifetime. When the structure is deprived of the positive effect of timber ties, the strong regions become weak regions of the building. An engineer, in order to intervene to a historic structure, follows the steps a medical doctor follows. The first step is diagnosis. Id est, identification of the reasons why damages occur to a structure. Like the medical doctor, the engineer has to acquire information about the state of invisible parts of the structure. To serve the needs of our work, we borrow techniques from other scientific fields. From all the listed techniques, we concentrate on radar and endoscopy because during a laboratory visit, demonstration of those two techniques is planned. Through radar, we can locate interfaces or different materials or regions of high humidity or voids or metallic objects within the thickness of masonry. The application of this technique in combination with endoscopy allowed us to identify the way masonry is constructed within its thickness in the case of a major Byzantine monument.